Now we'll be solving question number 18 from previous year problems. Chapter is laws of motion, phase 1. This question came in 2012. This is a mathematical sort of question. Let's see. A particle of mass m is at rest in the beginning, obviously, at the origin. At time t0, the particle is at x0, at t0, and velocity is 0. That's the information we have given. Now it is subjected to a force F as a function of time along the x direction. Now its speed is depicted by which of the following curves. So 4 curves are given. We have to check which one will be representing its speed properly. Okay. So the force is given, and from the force you can calculate the acceleration. So the value of force is given as F naught e to the power minus bt, and the force will be equals to a. So acceleration I'm getting as F naught by m e to the power minus bt. And acceleration I can write it as dv by dt. That's a differential equation, very first differential equation. So let's go for cross multiplication. So I'll take the t here. So we'll get dv is F naught by m e to the power minus bt dt. Let's integrate it. So when the time was 0, velocity was 0 according to the question. And when the time is t, velocity is, we are taking it just, so it's my habit, always keep the upper limit as a variable. So if I integrate this, I'll get v minus 0 equals to F naught by m minus 1 upon v e to the power minus bt, 0 to t. The velocity, I get it as F naught by b. This minus I'll take inside. First I write t and then I write 1. So I'll get 1 minus e to the power minus bt after calculation. Now velocity was 0 at t0. That was given. Now when the time is infinity, according to this equation, velocity, when the time is infinity, this whole value will become 0. And at infinity, you'll get the velocity as f upon mv. So as you see, as the time will approach towards infinity, the velocity will be constant. In the beginning, it is 0. If I check, all 4 options are starting from 0. There is no issue. No issue here. There is no issue. There is no issue. Then the fourth option, the velocity at infinity is moving towards 0, which is not possible because actually according to our calculation, it is coming out to be constant. A option also, it is at t infinity, it is becoming 0, so not possible because it is coming out to be constant. The option B and the C, at t infinity, the velocity is becoming constant. In first case, it is becoming F naught by m. In second case, it is becoming F naught by b. My calculation is F naught by mb. So option C is the correct option. So this is purely mathematical question. Some of the question you find this way as well. Okay. Thank you.